Welcome everyone to the session. Today's session is AI for data engineering, the good, the bad, and the ugly. We've brought together this outstanding set of analysts and vendors to really speak about AI-driven innovations that are revolutionizing data engineering. So as Ryan said, this is kind of an open mic session, a format where we really want to have a lot of participation, so get ready to bump up your interactions. Before I introduce the experts, let me first address this idea of the good, the bad, and the ugly. I admit it's one of my favorite all-time movies, especially for you Clint Eastwood fans. But it's really the thing I like about the movie. It's basically a tale of the trials and tribulations of three rivals on this journey in search of buried gold. And in today's jam session, I like the journey metaphor and also the good, bad, and ugly lens. So let's talk first about the journey. And really, the journey we're talking about is how AI is innovating data engineering itself. Now, we could take this data engineering and AI from two different angles. One is like, how is data engineering improving AI, but your ability to perform AI? But what we're talking about is the reverse of that, which is really how is AI, demonstrably innovating the processes, the tools, the roles and responsibilities in the data engineering world. And so we'll talk about the good, which are the ways that AI is being applied to data engineering workloads. What are some of those capabilities, some of those advantages? What are some of those benefits? And then we'll also talk about the bad. What are some what can go wrong? What are some of the negative consequences of AI on both the data engineering work and the workers themselves, the data engineers? And finally, the ugly. What's some of that data engineering work that AI cannot yet accomplish, and thus has to kind of be done the old-fashioned ways, and what might be around the corner for getting those things done? So let me start with some introductions here. We'll start with Phillip. Given the hundreds of articles you've written, the times you've spoken in your 25-year-plus career as an analyst, Gartner, Forrester, TDWI, Hurwitz, Giga, I mean, the list is just incredible. I don't really think you need an introduction. So why don't we just go with, tell everybody what you're doing today. Phillip, what's going on?
Well, hey, Bob, nice to encounter you again, by the way. And yeah, I've gone into semi-retirement. And first thing I did after leaving Gartner was to start a small consulting business. So nowadays I have a handful of clients. Half of them are users, technical or business users from a wide variety of industries. And then the other half are typically vendor companies, consulting firms, and so forth. So with a lot of my, especially my user clients, a lot of the work I'm doing nowadays is to assist them with data architecture issues. And a lot of this is precipitated by the ongoing migration to cloud. So as Bob mentioned, I have spent a lot of my time in recent decades in data warehousing, but also related fields like data integration, data quality, reporting, analytics, and so forth. And all those tool types and the massive amounts of data that go with them are in many organizations still in process of migrating to cloud. And it's not the proverbial forklift. You can't just pick things up off of on-premises and dump it on the cloud. Oddly enough, forklift does work with some data sets and a few tools, but most of the time you need to re-architect as you migrate, because you want to improve things as you move to cloud. You also want to optimize for cloud environments. Which are very similar to on-premises environments, but in terms of the way that capacity is expressed and the way you pay for capacity on the cloud, that's really quite different. So there's a lot of work that has to be done to re-architect large multi-tool, multi-data set architectures for cloud. And one of the many things people are improving as they move are their data engineering practices, right? Because we do have the migration to cloud I mentioned, but also we have kind of a revolution going on now. I think a lot of it can be seen in this new term, data ops. So DevOps has been around for years, and established practice for developers who create procedural applications, operational applications, all kinds of business applications. For those of us who are creating solutions that are more data-driven, data ops takes what we've learned about increasing the productivity, creating standards for the developer environment, bringing them new tools, new capabilities, some of them enabled by AI, right? We're applying these thoughts in the world of the data engineer instead of the applications engineer.
A lot going on, a lot of challenges out there for companies, and good that you're still helping them. Barzan, good to see you again, CEO, co-founder of Kibo. Why don't you tell us a little bit about Kibo and what your role is there and what's going on there?
Great to reconnect, Bob. Thanks a lot for having me. So yeah, I co-founded Kibo, which is a fully automated, the first fully automated data learning platform. But prior to Kibo, I was a professor at the University of Michigan, Ann Arbor. Before that, I was at MIT, and before that, I was at UC Berkeley and UCLA. Before that, also worked for a number of companies along the way. So I come from the intersection of academia and industry. My background has been, I've spent the last, let's say, decade and a half, more than a decade and a half of my career doing research at the intersection of machine learning or AI in general and database systems. A lot of my research agenda in my career has been all about like, how do you use, like long before LLMs and Gen AI was popular, my whole research career was about like, how do we use machine learning or AI in general to build smarter data systems, where smarter could mean faster, more scalable, easier to use, easier to deploy, et cetera, et cetera. So some of that work we've done it like, in the context of transactional databases. Some of that work is now running on millions of MySQL servers. But some of that work we've done it in the context of analytical databases, or what we call today data warehouses, and essentially that's where my journey at Kibo began. Right, like we realized that now it's the right time to bring a lot of those good ideas to life, and the market was ready, the need was there, the field, AI in general had reached a certain level of maturity where we could actually rely on it to solve real world problems. So that's how Kibo was born. And we've been helping enterprise customers and mid-market customers with their variety of their Snowflake cloud data warehouse problems, automating a lot of what data engineers used to do manually with AI. So this is an area that's very dear and near to my heart. Super excited to be on this panel.
Great. And how many customers now, Kibo? I know you can't give the details with a private company and that sort of thing, but plus or minus range.
Many. We have many large customers. You can find them on our website. Costco. We have customers of actually many different industries. Costco, Logitech, Freshworks. You can find a lot of public companies as well as a lot of mid-market companies that are relying on Kibo to save millions and millions of dollars every year on their cloud data warehousing bill.
Great. Arnab, good to see you again. It's been less than 6 months since we talked about a similar subject area, which is AI's innovation and how it's impacting data engineering. Lots has changed since then. LLMs just continue to be the topic du jour. What's going on over at Trends? Tell us about the company. Tell us about your role there. Is VP of Data Engineering.
I lead the data engineering practice at Credence, right? And we are a 2,500 odd people company, and especially very deeply entrenched in the RCG space, if you will, right? The retail and consumer goods space. We work with the 8 of the top 10 retailers, 7 of the top 10 CPG giants, and we've been grappling with a lot of enterprise data migrations, right? From Teradata, from SQL servers, Oracle onto cloud, etc. And looking at, as I think Phil said, how to optimize that, how to make that journey shorter, right? And how to make it, faster, better, cheaper, right? So that's what we've been grappling with, especially looking at the LLM ways of conquering things. It's no longer, right, you just move the data, build a data model on top of it, etc., right? So people are looking at avenues, right? So experimenting a lot with the DALLs of the world, the all the other ones, LangChain, DALL-E, etc., the different Gen AI capabilities that's required, and trying to infuse it into data engineering. That's one part of it. Of course, the others, of course, we've been constantly working with our constant crib from our customers has been on cost monitoring and observability, and how can you get AI into it, right? How can you optimize the cost? How can you optimize the cluster sizing, the storage, etc.? Then, of course, MDMs is another space where I see a lot of AI being used, especially when you're looking at merge and match operations. How can you create the golden record not by rules, but by using AI. We've also built a AI-driven data quality engine called Sancus. Basically, it sits downstream or upstream from an MDM. It also has got anomaly detection rules inbuilt into it. And the other thing that I've been working on is, of course, the Copilot part of it, or if you look at Tableau, it's the Tableau Pulse, making a BI truly self-serve using AI and providing it with the enough fodder so that you can get the right dashboards out through prompt engineering, so that your overall journey towards self-service is shortened for the consumers. That's what I've been working on. Happy to talk to you all today.
Great. Well, there's lots going on. Sounds like a lot of leading right into the good. You talked about observability and cost, Arnab. You've done a lot of your work. Barzan has been in that area. So tell us some of the good that's coming from AI in terms of data engineering for cost, from help manage some of those cloud costs that both Arnab.
Well, that's a great question. I think I would start from the high level idea of, okay, what's AI good for? Like, when do we usually turn to AI? When do we turn to machine learning, right? So if you think about from a very high level, there's four major categories or four major characteristics that when you see it, you want to start thinking about, how do I leverage AI, right? One of them is very large and sometimes complex corpus of data, right? Whatever kind of data it is, right? Way beyond what humans can digest, make sense of, right? That's the first thing. So large volumes of data. Whenever the task is tedious, it's something where no one's waking up in the morning saying, I'm dying to do that kind of stuff, right? I'm dying to go and walk, look through billions of rows of telemetry data. No one wakes up in the morning wanting to do that, right? So the second thing is something tedious. Humans don't want to do, right? The third thing is something where you expect some sort of real-time reaction to, right? Data engineers, for example, they're not dreaming about oh, I wish I could get that. I wish, I pray that I get a notification on my phone at 3:30 a.m. to wake up and do something, right? Something where you can't wait until the next business day, something that you need to respond to. And the fourth thing is cost consideration, right? Whenever it's basically about scale, getting more humans with skills is cost prohibitive, right? So those are the four things: volume of data, volume/complexity of data, cost, the tedious aspect of it, and the need for real-time part of it, right? So that's where we turn to AI, right? Now, if we sort of look at your question, okay, what are the good places? What is the good about using AI for data engineering? Then again, we'll repeat those four questions. What are some of the areas where those four boxes are checked? So if you think about it, data warehousing is where, cloud data warehouses, or data clouds, the likes of Snowflake, BigQuery, etc. One of the amazing things about them is that they've lowered the adoption barrier, right? Now, anyone in any organization of any size can easily tap into data without having to require massive upfront investments and training. But the side effect of it is that now more people are looking at data, and more data is being collected and being looked at. So, cloud data warehousing is definitely one of those areas, right? This is optimizing that infrastructure because of what Phillip mentioned. Back in the day, people didn't care as much about our Teradata server is running over there in that corner, no one's using it because you already paid for it. It didn't matter. But now you're paying it. It's a pay-as-you-go. When you're scanning data, you're paying for it. If it's BigQuery, if it's Snowflake, every second that warehouse is running, you're paying for it yearly and yearly. So now the cost is also a big concern, right? Yes, data clouds have lowered the adoption barrier, but they've increased the usage barrier. Now people have to spend a lot more on this. So now cost is becoming an issue. You don't have to be a big customer to spend hundreds of thousands of dollars on your Snowflake bill anymore, right? So optimizing that infrastructure is definitely another area where AI is definitely the good thing, right? Real time, again, if your pipelines are failing in the middle of the night over the weekend, you don't want to wake up a data engineer and say, hey, can you go and find out what happened? Hey, maybe I have a spike of load coming from my production. You need to go and bump the size of that warehouse. There is need for it because the world is not stopping. Your customers are using your platform. Your data has to be there 24/7, right? And then, if you think about it, it's also pretty tedious. We have customers with millions of queries every day. Even the best of, as I mentioned, all my career, I've been, teaching databases, building databases, and selling databases. I'm a SQL guy, but I don't dream about staring at, 1 million SQL queries, each multiple pages long, to figure out like what's wrong with this query. Like no one dreams about this. So some of those areas are basically optimizing your data infrastructure, optimizing your cloud data warehouse, optimizing your query, optimizing your performance, optimizing your cost. And there's a lot of other examples where it's all about data ops, how to do more things with less money and less time and less manual effort.
I love that lens, the four item lens, and I have to think of that: the good, the bad, the ugly, and now we got a different lens. So subject for the next jam session. Arnab, you mentioned cloud migration as a big area where you're doing a lot of work. How does, and it seems like that would meet some of Barzan's 4 criteria. Tell us about what kinds of things you're seeing in terms of applying AI and ML to the cloud migration challenge.
So absolutely right, and of course the first part of it is when we initially used to do cloud migrations, right? And there are different ways of doing cloud migration. There is lift and shift versus complete re-engineering and redeveloping everything, right? Now, different clients have got different preferences. And of course, as an individual, I prefer re-engineering. But there are licensing implications where people have to get off a system and they're like, get me off the system as fast as possible, right? So in such cases, we do lift and shift, etc. And that is where, if you look at the code, right? Say you're doing a Teradata migration onto Snowflake or a Databricks, etc. Right? You'll have to look at what you have and how can you convert it into something into the Snowflake world. That is where we've been seeing, and you'll have to. We initially used to do it through parsers, etc., which we had created, working with different kinds of vendors, etc., writing those rules, writing those patterns, etc. Now what we do is, set up an LLM, create RAGs around it, and see how much of it is actually able to convert, right? Whether you're using a GPT-4 or a Llama 2, etc., right? And constantly do prompt engineering to refine it and provide it with enough context so that your code gets refined, optimized, and is deployable in the cloud environment so that it runs smoothly. So that's precisely something we've been working on. Now, the other two.
Let me interrupt you there. So as you do that, and you're using this new technique, and your model's getting your LLM's getting smarter, what kind of benefit are you seeing in terms of either time to migration or unfortunately lower charges from credence to the client, but probably
there are 2 ways, right? Training LLMs is also not cheap. Okay. Training LLMs are costly, right? So that's something you'll have to keep in mind, whether everything you have to do is, do you need an LLM for everything, or you can do it with a combination of heuristics and LLM, right? So it's a bit of a balance that you have to strike, right? So but on an overall, from an overall perspective, first cut, you'll get there 20 to 30%, but overall cost savings around 30 to 40% in the development time that we would have otherwise invested is what I'm seeing. But this is in case of lift and shift. When you're rebuilding it, of course, you'll have to rebuild. There are no shortcuts, and that's probably the ugly. But there are no shortcuts there, right? So you'll have to build the data model. You have to look at the cluster configurations, etc. I just wanted to add to one point which which Barzan made, right? Apart from, of course, there is one angle of the cost optimization angle, wherein you don't want to be on the wrong side of cost, right? And then you're constantly looking at optimizing it. We've also built certain cost optimization models, right? Wherein what we've done is looked at the profile the data, right? Looked at the workloads, profile the data, and automatically, right, when you feed your AI engine with what should go for what kind of workloads, it will tell you what kind of cluster sizes or SKUs on Databricks, on Snowflake, on BigQuery that you should be using as a workload. So that actually, from a cluster selection perspective, because bear in mind, when you're selecting a cluster, you have to look at cost and performance at the same time. You just can't look at it from one lens. So that's where we've seen a significant benefit of AI, is what I would like to bring forward.
Phillip, let you chime in here. You've heard a couple of different areas of benefit. What do you think?
Yeah, like you said earlier, there's a heck of a lot going on, and there's so much to talk about, isn't there? But for years I worked in data warehousing, and I'm seeing some of my clients who have data warehouse backgrounds attacking the large language modules, and I'm seeing some of them following some techniques we used to apply in data warehousing, still do actually. Data warehouses tend to be built one domain at a time. You can think of it as a data domain, or really it's more like a business domain. For example, you can think of customer data as one of the more primary data domains, but it's represented by certain departments that depend on customer data. Marketing department, financials, all kinds of departments can depend on that. So at any rate, you typically build a data warehouse as a series of data sets. People think we say the data warehouse, but it's not one solid entity. Really, it's a collection of data collections. There are many data sets in a mature data warehouse. So we're seeing people approaching the LLM the same way. So they'll work on focus on some typically high value data domain where they know they're going to get some kind of return on the investment from the LLM. And, practically anything you do with customer data is going to get you some kind of return on it. That's the magic domain, right? And then later they work their way into a product domain and more operational domains like, measuring corporate productivity and so forth. If you're in a business that has a lot of business-to-business relationships or some kind of active supply chain, then eventually they'll start working supply chain and product issues into the LLM. And then, kind of the question is, well, we're building out this series of data models, which we're going to express through this LLM. How do we stitch it all together? And I've got one client who's taken a very innovative approach to that. I've talked to a lot of organizations who've looked at this newer type of database management system, the graph database. And so we're seeing people doing their modeling, and then they use knowledge graphs as the kind that are generated by a graph database to give them all kinds of high-speed indexing and also just sort of cross-domain insights and so forth. But do you see what I'm saying? The large language module, it involves a lot of modeling. It's not really your traditional data modeling, and yet some modeling techniques still do apply to it.
Another area of good, thank you, Philip. Another area of good we started to explore a little bit was maybe performance. We talk a little bit about managing the cost, and like in a cloud data warehouse, up in the cluster, down right, lower in the cluster is appropriate, and it kind of works fast, the insight, and then also do it quickly, save the money, but also performance. The tedious task of going through queries and trying to make them just slightly better, it's one of those victories. You can, if you're the first performance tuner, it's great. If you're the fourth, the marginal benefit is not that high. Plus, there's, as Barzan mentioned, hundreds of thousands of these queries running daily. Barzan, what do you see in terms of applying AI? How does that fit your model, applying AI to this kind of query optimization challenge?
And that's a very good question. So query optimization is not a new area, right? Like, it's as old as database systems, right? From the first day that people create the first database, the first question was like, if we're going to automate the evaluation of this, if we're going to be able to support declarative query language, which tells you what needs to be computed and how it needs to compute it, then we need a way of automatically optimizing those queries, right? But I think up until very recently, the main approach that a lot of customers, I should say a lot of data engineering teams and a lot of consumers and customers of data clouds have taken has been this idea, hey, why don't you give me a tool that tells me my most problematic queries, and then I'm going to go and stare at those queries. And if I stare at those queries long enough, hopefully I can figure out how to optimize them, right? So I actually wrote a blog post. I recommend people to look at it. It's like, there was this big story about, whether Instacart, because Instacart is one of the, this is nothing confidential, it's public information. Instacart is one of the largest customers of Snowflake, and there was this big, public debate about whether they're moving away from Snowflake to Databricks, et cetera, et cetera. But I wrote this blog post about how the likes of Instacart, what they've done is that they build these massive tooling internally, right? This is what data engineering teams do at these companies, where they put the lens on those queries that need help, and they basically told the rest of the company, hey, these queries are expensive, these queries are inefficient, please go and make sure you stare at them long enough. So instead of just having, instead of having a centralized team stare at the queries, now they distribute the work across the entire company. So my blog post was about like how distributing the manual work doesn't make it any less manual, it's still manual. But one of the so at Kibo, we actually have a way of automatically rewriting your queries. We call that query acceleration, smart query acceleration at Kibo, where you basically rewrite queries, and especially if you have a BI dashboard, you want to speed it up, we do that as well. But most recently, with one of my PhD students, we actually developed a new way of sort of optimizing queries using LLMs. We call this algorithm gen rewrite. So the idea was like, hey, if I can go to ChatGPT. So for those in the audience who may not know about what query writing is a very old problem. It's a very big and difficult and open problem, which the idea is, okay, this query, given a database query, SQL query, rewrite it into one that's more amenable to optimization by the underlying query optimizer, but yields an equivalent answer, yields the same answer as the original query. So it's a very difficult task. So for decades, the best people could come up with was like what's called rule-based query writing. So, right, so there's things like Apache Calcite, where basically there's, let's say 100 different transformations that they try, and sometimes they get it right, sometimes the queries actually get slower, right? But then the main limitation was that these rule-based systems are as good as the rules that you give them. Meaning, if you see a new query pattern that doesn't match any of your rules, then you're out of luck. Again, you're back to this game of keep staring at these queries, log it up, hopefully you come up with some ideas. So the idea was for us like to see, hey, can we actually leverage LLMs, large language models, and Gen AI to actually rewrite queries? And we started with ChatGPT, right? The baseline approach was take a SQL query, give it to ChatGPT, and say, can you rewrite this query into one that's faster but equivalent, right? So one of the biggest problems that everyone's aware of with LLMs is this idea of hallucination, right? That they basically can give you the wrong answer with very high confidence. So in most cases, it would actually rewrite it. Like, I don't think we ever encountered a situation where ChatGPT said, I don't know how to rewrite this query. It would always rewrite it for you, right? But more often than not, that rewritten query was incorrect. Sometimes you wouldn't even parse, right? Because LLMs cannot evaluate the idea. So the query wouldn't parse, it wouldn't make sense, or it would parse but produce a wrong result. So we actually created a process around ChatGPT and LLMs that actually allows us to use LLMs in a way that rewrites the query into one that's equivalent but significantly faster. So, we took one of the most complex benchmarks in the industry, which is called TPCDS. This is the benchmark for decision support, very complex queries, already highly optimized. We were able to actually optimize some of these queries by sometimes hundreds of times, on average by 5x, with just leveraging this algorithm that we built around LLMs, where we iteratively let the LLM actually learn about query rewriting. So when it gets it wrong, we go back and say, hey, can you come up with an example that these two queries produce different results? And then we take that example and then we go back and forth with the model. So we have sort of created this framework. This is not commercially available yet, but the paper is online. People can go read it. We actually have this framework where you can actually use LLMs to rewrite queries that even the best human experts could not rewrite successfully.
Wow. So kind of going back to this challenge of training LLMs that Arnab talked about. Phillip, 18 years ago, I journeyed to Lexington to see you, and we talked about query optimization. At that time, the problem was across a federated environment and using data virtualization. It's like the more things change, the more they're the same. Do you see that query optimization challenge with your clients?
Yeah, it's still with us. It's just the issues have changed slightly. And, I have a pretty high opinion of the Snowflake environment. I mean, if you want to build a fairly traditional dimensional warehouse, it's a good solid platform for that. But it's still kind of a new platform, and it's got some holes in it. And one of the holes is query optimization. And related holes would be things like financial FinOps, as we call it at Gartner, financial operations, and that will help us, and also FinGov, financial governance. How do we govern our costs in a cloud environment? And so it's not just Snowflake. With a lot of the data-oriented cloud providers, the longer your query runs, the more money they make. The more times your query touches their database, the more money they make. See where I'm going with this? The more data you move around, the more money they make. So it behooves you to fill the gap in Snowflake and other environments and get the best query optimization assistance you can get. And don't forget, that's been part of data engineering forever, and that's been a real time sink. And it's just exactly like Barzan was talking about. Your high payroll engineers spend a lot of time looking at this query that they've looked at 100 times and expect to see something different, the 101th time. And so any help you can give those guys, you will increase their productivity. They'll spend less time, high payroll time, trying to fix something that we're getting to the point where AI and other tooling can assist us with. Query optimization is not new, and it's had various types of automation in the past, right? All kinds, a wide range of algorithms built into the optimizers. Also, a lot of organizations, a lot of tool types have created automation for the data engineer through business rules. This has especially been the case with a lot of the ETL tools and especially data quality tools I've used over the years. Mm-hmm. So we're starting to see some of these older forms of automations being applied to query optimization, but also to kind of broaden this out, Bob, and talk about more areas of the data engineer. We're seeing AI and especially machine learning capabilities being built into a wide range of data management tools. For example, if you're doing ETL and you're just mapping source to target, then that's a very well understood problem. It's time consuming. Since it's well understood, we can write algorithms that can do that. And we can extend that with machine learning, where the machine learning component of your ETL or data integration platform, it watches you as an engineer, and it watches your colleagues who are engineers, and it knows that given a certain context, that there's something you guys typically do as engineers. So the recommendations that come through simple machine learning, even though it's not full-blown AI, right? It still makes really good recommendations. And that's what a lot of AI does nowadays. It makes recommendations, and there's still human intervention. We look at the recommendation, whether it's a data engineer getting a recommendation for a data mapping, or whether it's a recommendation about a potential new market segment that a tool tells a marketer end user. See what I'm saying? We're getting a lot of recommendations already, but we assume that we need to look at the recommendation as humans, and we make the determination and so forth. Bob, to kind of stretch this out even further, at Gartner, we started using this term autonomous AI. And autonomous is where we don't just get the recommendation, we trust the AI so much that we're going to let it automatically take action and remediate that data quality problem it just had without a human looking at it, to just create the interface for that mapping that it just discovered without some human looking at it, or in the future do all kinds of stuff without human intervention. And I got to say, the marketplace in general is not at the trust level yet for that. You see what I'm saying? And Bob, that's part of the it's kind of the bad, or maybe the ugly side of the good, bad, and ugly. That we need more time. We need more time for people to get used to using AI and build trust. We also need just more operational time with AI, so we can go, okay, we've been using this tool. It's been through this 10,000 times, and 98.5% of the time it was right. We had a human look at it, so now we trust it enough that we can put it into a real-time operation instead of being an offline human approval process. See what I'm saying? So there's a lot of this going on right now in a wide range of tools, from query optimization in the DBMS right on up to your data quality ETL tool. And at Gartner, Mark Beyer came up with this concept of active metadata. That's where you have machine learning and AI algorithms that are able to just look at data and bang, produce a metadata entry to go into your metadata repository. And you know, if you're onboarding several new data sources a day, you don't have time to do that yourself. You need as much automation as possible. But you get the idea. AI and kind of at a lower level machine learning, that stuff is coming in for these areas where we've been struggling as engineers to be productive. But we're hoping that the automation we get from AI is going to take us up to the next level. We're gonna demand more trust through more precision before we get to the trust level. But eventually we will get there. Eventually we will have what we started calling autonomous AI.
So to summarize that a little bit in the good, the bad, the ugly model. So yeah. The AI is actually creating some good, saving the engineering time, and it may be an 80-20, which is just recommendations, yeah. And you still have to, observations and recommendations, you still have to do the work. And then other cases, you know, bad is bad, you know, as Barzan mentioned, you know, it could be a bad query result because it optimized something and worked on optimizing the query as opposed to making it correct, keeping it correct. Barzan, a quick question for you on this autonomous piece. You talk about observe and execute in some of the white paper, and I'll come to a moment. I want to next I want to introduce Tim, editor at Solution Review. Okay, so while Tim comes on, Barzan, what do you see in terms of overcoming that human barrier? Because you're making recommendations in terms of upping the, you know, the cluster size, et cetera. You know, people trust you, or do you?
I actually love the setup that Phillip explained. He's spot on. So that's actually one of the main things that we decided very early on, was that we don't want to be a recommendation tool. If you think about those 4 things I mentioned, well, like if there's a sudden increase in the spike, do I want to make at like 3 a.m., do I want to make a recommendation and wait for a human approval? By the time that human basically wakes up and sees that thing the next morning, the spike is gone, the damage is done. Likewise, if I suddenly see a opportunity to cut your cost by 30% in the middle of the night over the weekend, do I want to wait until someone approves it? So this has to be real time. So we are actually that autonomous AI that Phillip mentioned. So we're not just saying, oh, I think you can downsize this warehouse, you can change this problem, you can do this. We're basically a fully automated solution. We are going there, we do the optimization, like an autonomous car, right? Like what we're doing is hard. The challenge with doing hard things is, you can't cause slowdown, because our first slowdown is our last slowdown. So we've actually built in a lot of guardrails into our models to make sure we don't cause slowdown, because we want to save money for the customer, but if we cause slowdown, then they're going to lose their trust, right? Like think about the analogy of an autonomous car. Your first crash is your last crash, right? So for us, the same thing. If you're a fully automated warehouse optimization platform like Kibo, then our first slowdown is usually our last slowdown. So how did we do this? I think we think about it in terms of 3 types of barriers, as Phillip also alluded to it, right? One of them is the implementation barrier. Like if you have to go and hire a team of data scientists and spend month on month debating your data, cleaning your data, that's a huge step, right? So implementation, the way to overcome that first barrier, the implementation barrier, is to make sure there's no code needed, no migration needed, it's plug and play, right? The second barrier is a trust barrier, right? Which is actually a higher barrier, trust / I would call adoption barrier, right? For people to trust your solution, you have to give them control. People need to feel like they're in control. Even if you're on autonomous mode in your Tesla, you need to feel like you can actually change the course. So we give people all those things where they can actually set up the parameters that they're comfortable with letting Kibo have scope in terms of what to optimize. And over time, they actually give us more and more freedom, right? But the other way of actually overcoming that trust barrier is time to value has to be insanely short. So instead of us going there and say, hey, why don't you let your hands off of the steering wheel and come back in 2 months from now, we discuss success criteria, most of our customers start seeing savings within 24 hours, right? That short time to value, I think, is not the entire story, but a very important part of earning people's trust. And the third one is the privacy / security barrier, right? Whenever you talk about AI, people are concerned about hey, how is my data used? What if you learn from my data for someone else? So that's a much bigger, subject that I don't want to get into. But the way we've overcome that third barrier at Kibo is that we kind of solve the problem by erasing it, by saying, you know what, we don't even want to see your data. So every model at Kibo is trained exclusively on customer metadata, essentially on telemetry data. So not only do we not store customer data, we don't even see it. So that's how we've done it.
All right, thanks, Barzan. I'm going to come back to you in a second, Arnab, but Tim, we've covered a lot of stuff. We're just scratching the surface. Details would be helpful. Where can people get some of those details? The Insight Team members.
Yeah, great. Thanks for having this insightful conversation on AI and data engineering, you guys. It's been a great start to the conversation. Yeah, I just wanted to pop in as the executive editor here and make some recommendations for further reading for you guys, for the community mostly. The first one is Kibo's guide to using AI to save money in Snowflake, right? So this is a great guide. We made it a key part of our newsletter this week. The guide goes over advice for reducing costs, potential pitfalls for cost optimization in Snowflake, AI best practices to look at, and more. So I mentioned the guide, I mentioned the newsletter. Solutions Review runs a weekly newsletter in data management and data science each week on LinkedIn and on solutionsreview.com, where effectively we cover all the innovations in AI, data engineering, and data science from providers like Kibo and Treatance, and many, many more. So check that out. That'll be live on LinkedIn and, like I mentioned, solutionsreview.com today. Also, another great piece of content that I can recommend to the community is yesterday's mini jam session. So yesterday we ran several panels. We ran 4 hours of expert panels with more than 20 experts, all discussing topics pertinent to the AI conversation. And that's ultimately what we're trying to enable with Insight Jam, LinkedIn, and all the Solutions Review content that we're writing. We're really trying to enable that AI conversation for our community, for the vendor executives, and for the experts like you, Bob. So thanks again for hosting. I just wanted to pop in and provide some further reading, and I'll drop the link to those pieces of content in the comments here.
Great, thank you, Tim. Arnab, we've talked about time to value, trust and control. As a services firm, I mean, those are like core principles in your business. And as you're applying it to this area, do you see parallels between what you have to, the earned trust that you have to have, and the kind of innovation you need to do, and the sorts of things you're seeing in this AI domain, AI for data engineering?
Okay, so I'll just narrate one. I will talk about a few incidents that I've faced, few experiences. Maybe that'll make it more real. So I was working with one of these large retailers, and then we used our AI ML driven query optimization model, right? And we projected a cost savings of an annualized cost savings of $1.4 million. Okay, what we did was we looked at the top 20, top 30 offenders, right? And once we looked at those offenders, we got to the cost savings for each one of them, right? The moment the people who were actually running the pipelines, etc., and we were coming in from an outside-in perspective, and the moment we took it to them, they said they shot down everything. Okay, they're like, I don't care what your machine says, I've got rationale for everything, right? So that trust factor becomes very, very important, right? To make them believe. Okay, so you'll have to work with them, make them feel empowered, as Barzan said, right? And make them feel that they're in control. Once we are able to do that, I think from there on, it's straightforward. But that initial trust is very, very important.
So humans are the good, the bad, and the ugly.
Human in the loop, yes. Human in the loop is.
Yeah. Well, we've gone quite a while here, nearly 50 minutes. And I just wondered if each of you guys could take just a moment on a final thought. What would be a good one or two takeaways that you would think from today's session for the audience? Phillip, start with you. What are a couple of things that you think might be valuable for the kit bag of the watchers today?
Well, to use your paradigm, I think one of the good aspects is that AI in general, more specific forms like predictive analytics or Gen AI, I think that shows tremendous promise to raise process automation to the next level. Whether that's AI that's going to help process automation that's built into every ERP, right? Or it's process automation to help the data engineer, as we were talking about earlier. And don't forget, that's what software is. Software automates processes. And what is AI? It's software. A lot of times people get the software of AI mixed up with the hardware that it's in. For example, a lot of people think AI and Android are the same thing. No, they're not. An Android has a lot of AI running in it, but that doesn't mean the two are the same thing. So you have to explain the differences there to a lot of people. I think that's part of the human failure. We haven't defined AI carefully enough for wide people to get to it. So that's part of the bad and ugly, is that when you're trying to pitch AI to your management where you work, a lot of them have strange notions of what AI is. So you don't be shy about backing down and giving these basic definitions so they can understand it better. I think part of the really ugly part is mistakes will be made. And that's part of the trust building process as we start to trust AI to do more stuff automatically. I mean, recently a big ship hit a bridge in Baltimore because some sensors in their logic decided that they were overheating the diesel engines. So to save the diesel engines, they killed all power on the ship, which is insane, which then just created a bigger problem. So you get the idea there. Recently, there was a weapon strike that where we think some commander let the weapon decide what the target should be. So stuff like that. Those kind of mistakes will erode our trust for all kinds of AI. See what I'm saying? So expect there to be some mistakes where you trust your AI to create those data mappings I talked about. And over time, you realize that wasn't the best decision after all. But, again, it's like the 80-20 rule you mentioned, Bob. If you can get 80%, you're actually doing quite well. But with AI, I think the ultimate trust before we turn it loose to autonomous AI, we got to get to a lot higher trust level than 80%.
We don't want your first crash to be your last crash. That's classic. Arnab, a couple takeaways from you.
This is what I'm going to say, right? Of course, the promise and potential is for everyone to see. And I have felt it firsthand with the experiences that I've had on different technologies. So if you're looking at cost monitoring, observability, compute sizing, MDM, migrations, AI-driven data quality, right, where you are doing anomaly detection, etc. All these are good use cases, right? But the human in the loop is important. The trust factor is important, right? The workforce should not feel uneasy, okay, and they should be able to understand what is going on. They should be able to, keep abreast with the huge learning curves. Hallucinations are things that we'll have to deal with as they come along our way. There will be stray patterns which break through, but we'll have to, think about how we can work around them. But your ingestion, modeling, source to target mapping, business transformation rules, these are not going anywhere soon, right? There's time, and of course there will be a time when things will change, but it's not now.
Great, thank you. That's well stated. Barzan, give you the last word here.
So I would say, like, we live in really exciting times. This is an amazing time to be alive, right? Like, finally the technology, the AI technology has reached a certain point of maturity where it can actually take things to the next level. AI is not new. What's new is that it just got to a tipping point where we're able to sort of let go of a lot of things, right? Like if you guys asked me 5-6 years ago, what are the things you don't want to go to AI for? I would say, like, open-ended question, like creating, creative content. All of that stuff has changed. I think we're at the turning point. It's happening. Like, my advice to anyone who's interested in this space in data engineering is to start, like, training themselves, like, investing in their own career by learning about AI, by using AI powered tools, right? If you're using data clouds in any capacity, you want to look into using AI, whether it's for reducing your bill, for optimizing your performance, for automating a lot of the tedious aspects of operating it. But, just invest in yourself and invest in your company learning and adopting and using and improving AI tools.
Great. Well, it's kind of interesting today. If you really think about the adoption and enabling that, the vendors are helping. I mean, you have people, from an architecture point of view, like Phillip, who kind of guide you into an architecture that's going to be enabling. You've got I think one of you mentioned the ETL tools are doing a better job of moving from just heuristics to more intelligence in that. So the actual vendors in the data management arena itself are embedding AI to make their processes and tooling work better. You have specialist firms like Kibo who exist to provide these AI enabled data engineering tools. And then you have firms like Credence who can bring the people aspect and the tools together and enhance and enable your team. So I think that's really optimistic as well, because people, the users out there that have the real jobs, they have a whole community of help that they can draw on, and it's fun to be part of Insight Jam and present all that great opportunity. So I want to thank everybody for joining today. Certainly our experts, our speakers, a fabulous job, and I encourage everyone to just stay involved in these Insight Jam sessions and learn about all the great stuff that's going on.